don't forget to subscribe and share. Thank you.
All right, thank you so much for joining us again. And in this video, I have 70 multiple choice questions that we are going to go through together. And don't forget to get one of the advanced textbook for yourself. And it's very good to, it's going to help you to stay ahead of the class. And most of the time, majority of the questions are also coming from the book. So it's good for you to get one of the textbook. And don't forget to also grab your Merbs series. It's very good. Buy some to support Merbs Connect, to grow, to help students, to do a lot for you guys. So let's jump right in. So here we want to find domain, and this video should have been after we have started learning advanced with me. Then I'll be doing it, but because of your quiz I'm doing this, so some of them is going to be confused, or you are going to get confused because maybe you don't really understand, but I'll do my best here to assist you. So make sure you pay attention, stop everything that you are doing, grab your pen and sheet. Let's learn together because quiz is just very soon. So let's just jump right in. So here we want to find domain of the function, right? So what is domain? We want to exclude the values of x plus y minus 1 such that this function is what? Undefined, right? So we want to just pick this one and see how we can work with this. So what I'm going to do here is very simple. I'm going to let f of x, y to be equal to z. When I do that, it means I'm going to have z is equal to sine inverse of x plus y minus 1. And here I can pick sine on both sides to have sine of z, which is equal to x plus y minus 1. So I just move this inverse to this side and I have this. So because we are looking for the domain for this, and this is the same as this, then we can now work with sine of z, and then the result that we are going to get will be the same as this. But what is sine of z? Now we know that sine is bounded by -1 and 1. So the domain is just going to be this here. It's going to be -1 less than or equal to sine z less than or equal to 1. And we know that this is the same as this. So we are going to have this one to be -1 less than x plus y minus 1 less than 1. And this is going to be c. Very simple with this one. Please make sure that you follow along so that you understand how to solve it, right? Now, this question is very technical but very simple to work with. So we have v, which is equal to x square root of 1 minus y squared plus y square root of 1 minus x squared. And then we have u, which is equal to sine inverse of x plus sine inverse of y. But from the hint, we have a to be this and we have b to be this, and that one is very good with that. And they've given us even this, so we don't need to struggle a lot here. So a is equal to sine inverse of x. This implies that x is equal to sine of a. So what did I do? I just find sine of this, find sine of this. So this one is going to cancel, so I can just write it this way. This is the same as sine a, which is equal to x. So this is true. We have b, which is also equal to sine inverse of y. So this also implies that sine b is equal to y. Nice. Now what can we do? Now let's try and do substitution. I'll use blue to write this. So now my v will be equal to x is equal to sine a. So I'm going to have sine a square root of 1 minus, what is y? Y is sine b. So this is going to give us, y is squared here. So this is going to be sine squared b, right? Plus y is still sine b. And then we are going to have square root of 1 minus x squared. X is sine a. So I'm going to have sine a squared of a. Now what are we going to get here? Now this is sine a square root of, now let's use one of identities. 1 cos of x plus sine of x squared, this identity here is equal to 1. So if I'm using a and b, then cos of squared a plus sine of squared b, a again, is equal to 1. So here, if I want to make a the subject or this the subject, then I can move the sign to this side. So I'm just going to have cos squared of a, which is equal to 1 minus sine squared of a. So if this is b, this one too will be b. So this is just cos squared. So we are going to have cos squared of b plus sine b, and this is just going to be cos squared of a from the identity. Now this square here can cancel the root, this square here can cancel the root. So I'm going to have v to be equal to sine of a cos of b plus sine of b cos of a. And this is an identity. Remember that if I have sine of a plus b, a sine of x plus y, this is the same as sine x cos y plus sine y cos x. So when you look at what is here, if my x and my y is ab, then what is here is the same as v is equal to sine of a plus b, right? So that's what we are going to get. We don't need to find for u, right? Because we can see that u is even a plus b, but we can find for u. How are we going to do that? We know that sine inverse of x is a and sine inverse of y is b. So it's going to be u is equal to a plus b. So now we have u, which is equal to a plus b. So we want to find the relationship with this, right? So look at b here and look at u here. You see that we have a plus b, a plus b. So for us to get sine a plus b, what we can do is we can find sine on both sides here. So this implies that sine u is the same as sine a plus b. And we can see that this is the same as this and is the same as u. So therefore, u, sine of u is the same as v. So that will be the relationship. So I can write this one as u is equal to sine inverse of u. So let's go to the options to see if we have v is equal to sine u. Yes, here. So that's what we are going to get for that particular question. I love advanced calculus a lot. It's very easy, but if you don't study it, it's going to be so complicated, right? You just need to have time to work through things. Okay, let's look at this here. This is a chain rule question, right? So we have z, which depends on x, y, and x depends on r, theta. Y also depends on r and theta. So I can do this, I can write this one as z depends on x and y, which is here. And then x depends on r and theta. So I can also have another branch which depends on r and theta. And then we saw that y also depends on r and theta. So this one will help us to perform this. So now we need partial derivative with respect to r. So with respect to r, now when I'm on this branch, I can see that I can move towards x and get to r. I can also go this way and get to r. So it means that we are going to have some. So for me to get to r, I need to pass through x before I get to r. So it means that first, I'm going to differentiate z. And when I differentiate d, it should be going with x. Then I have with x times, then now I'm at x. So and I'm going to move from x to r. And this is going to be times x and r. So that's basically what we are going to get here. Now let's go to the other side, because the other side too, we have r here. So I'll pass from z to y and y to r. So first, I'll start with z and then I'll get to y. Then I'll move from y to r. So I'm going to have times y to r. So this will be our equation. So all we just need to do is, now we know that x is equal to r cos theta, right? So we can differentiate, since we want partial of x with respect to r, we can differentiate this with respect to r. So partial of x with respect to r is going to give us cos of theta, because when I differentiate r with respect to r, I'm going to have 1. So this is just going to be cos. And then we also have y, which is equal to r sine theta. And when I differentiate partial of y with respect to r, this is going to give us sine theta. So I can just do a little substitution here. So I'm just going to have partial of z with respect to x times cos of theta plus partial of z with respect to y sine of theta. So let's just check through and see if we can see our results here. Okay, so sometimes advanced is just complicated. Sometimes you can get it right and choose the wrong option. So sometimes open your eyes to see. So I can see y with cos. So definitely this is out because the y is going with sine. So c is out. I can see y with sine, which is great, but this is minus. So this is also out. Let's come here. I can see y with sine here, and I can see x with cos here. So the answer here is going to be B. So please open your eyes when you are doing the selections. Now, because we are using this one to solve from 3 to 7, I need to also differentiate. So let me just bring this one down here. I'm just going to differentiate this one again. So let me differentiate x with respect to the other variable, which is theta, because we are going to use in the next one. So when I differentiate this with respect to theta, r is constant, so it's just going to be r. And when I differentiate cos, I'm going to have minus sine theta. So this is going to be minus r sine theta. Then when I differentiate y with respect to theta, r is constant. And when I differentiate sine, I'm going to get cos. So this is going to be this. We are going to use this below. So let's go to question 4. Question 4, we want to differentiate this with respect to theta. So let me go and bring my information down here so that we will see what we need to do. Great. Or I can even just pick this guy down, 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 down. Let's bring this diagram again. Sorry. Oops. Great. Oh, nice. Very good. Then we need these two guys too. Let's send them down there because we need them. Great. Let me just put this guy here. Now we want to differentiate z not along r but along theta. So I pass through z, go to s, but now I pass here to theta. I goes to y and then now here to theta. So it's going to be very simple. Partial with respect to z, theta. This is going to be now from z to x and x to theta. So think about z to x, then x to theta. Very simple, right? Good. Then now I pass through z to y and from y to theta. You do this more often and you'll be great. You'll be good with this. So now let's do substitution. So I know that this guy is here and this guy is also here. So this is just going to give us z x times minus sine theta plus z y times r cos theta. So let's go and find out if we have a result. Okay, I think they did some small simplification there. So let's also do some minus out because I multiply by minus. This is r sine theta plus, with respect to y, r cos theta. So let's check out. So let's eliminate some of the options. So let's start from A. Okay, I can see this is the same as this. Is this the same as this? Yes, so we don't need to even struggle. This is the results. I hope that is right. Of course, advanced is, you need to open your eyes because the options are very, very similar to each other. So if you don't pay attention, you get it wrong. All right, let's look at this one. So this one is we need to differentiate this with respect to r, then we square it. But remember, we've done this one already. We've done partial of z with respect to r. So we don't need to go through this process again. So I'm just going to bring that guy. So that guy is here. Partial of z with respect to r is already done. So let me just copy this. So advanced, if you want to solve everything again, you won't finish. So you need to be very smart and very fast and know what you are doing, I mean. So now that we have this, we want to square this. So partial of z with respect to r squared is going to be partial of z of this cos of theta. Well, let me write well. The questions are a lot, so I want to speed up small, but I'll make sure I explain it to your satisfaction. Okay, so think about this square here as a plus b squared, right? So it's going to be a squared plus 2ab plus b squared, right? So that's basically what it's going to be. So this is my a and this is my b. So let's just do substitution. So this is going to give us this with respect to x squared, because we need to square a. This is my a, I'm going to square it. And this one will be squared theta. So I squared this, which is giving us this. In the middle, we have 2 of a and b. So let me just do it again. So we are choosing our a. We are choosing our a to be this with respect to x, cos of this, and we are choosing our b to be partial of z with respect to y, sine of theta. So now I square my a, which I'm getting this. Then this is 2ab, 2 times this and this. So this is going to give us 2 partial of z with respect to x, cos of theta, partial of z with respect to y, sine of theta. Plus, now I need to square my b. So when I square b, I'm going to have partial of z over this all squared. Now, mind you, this partial of z squared of this divided by partial of y squared is not the same as this. That's why this does not mean differentiate the function twice. No. But if this question was partial of z squared of z divided by r squared, then this one, what it means is we need to differentiate the function again. So here we could have just differentiate this function again. So pay attention with the symbols and everything in advanced calculus. Very, very, very important. Okay. So now when I square this one too, I'm going to have sine squared theta. So let's go and check it out and see what they had. Okay, they combined some of the functions together. So let's do that. So what they did was, okay, partial of z with respect to x, all squared, cos squared theta plus, then they brought this one again. So plus z with respect to y, all squared. Then they combined this one, last one. So this is plus 2 partial of z with respect to x, partial of z with respect to y, sine theta, cos theta. So let's go and check it out. We should be having something like this squared with theta. So let's go and see. The one with this is x with the cos. So this is basically out because this is y and with the cos. So this is out. A is out. This is with y and sine, which is true because the y is with, oops, I left the sine theta here, please. Okay, so this one is also squared. So y is with the sine and x is the cos. So we can see that y with the sine squared, x with theta squared, and we have 2 this cos theta. Yes, indeed. So we are going to pick this one. We don't have any negative, so this out, this out. So the answer should be B here. So as I said, I'm keeping reminding you, pay attention to. Good. So 6-2, we need to square this. We need to square this. Good. We need to square this. So let me just copy this and send it down there, and then we just do that. Maybe I'll leave this one for you to do. Let me think about it. See if you want me to leave it for you to check and then find out the answer here. So yeah, I think it's worth leaving it for you. So what you just need is do the same as we did for squared, right? Do the same for as we did for this with the expansion here, and comment your answer and write your final answer in the comment section. Right, so try this one and let's see if we are going to get it right. Okay, now let's move to question 7. Oh no, I need to do question 6 because we are going to use it here. This is very terrible. Okay, fine, let's do it. So good. All right, so we are using the same thing again. We are using a plus b squared is equal to a squared plus 2ab plus b squared. Now here, our a is this and our b is that. So this is going to be, now when I square minus become positive, take note of that. So this is going to be this divided by x all squared r squared sine squared theta. Nice. Plus, I need to take 2 of this and that. But because it is minus, this will be minus. So I'm going to have minus 2 of partial of z with respect to x. Now I want to write this one because I want to multiply this and this. But okay, fine. I can still keep it that. R sine theta and then partial of this with respect to y, r cos theta, plus, b squared. So let's do b squared partial of z. So you see how the questions are. If you get one wrong, you are dead. Assuming that I'm getting the first one wrong, or assuming that when I did this one, there was no minus, it's going to affect the whole solution. So you see that advanced calculus questions are dependent questions. It depends on the previous one. Most of them, you can have like 5 questions and all depends on the previous ones. So if you get it wrong, you get it wrong. Okay, so I think they've grouped like terms there with first x. So let's do that. So this is the same as partial of z with respect to x, all squared r squared sine squared theta, plus partial of z with respect to y, all squared r squared sine squared theta. Why is it that I don't like writing square? Okay. Then minus 2 partial of z with respect to x, partial of z with respect to y, and this is going to be r squared sine theta cos theta. So r times r will be r squared and then sine cos will be this. So let's go. We know that x is going with r squared, x is going with the sine, and y is going with the, oh, are they all going with the sine? Oh, that's crazy. So this guy should be cos. So please pay attention. Sometimes it's just sometimes, right? You do the thing right and you get it wrong because of your computation. So please make sure you open your eyes, okay? TAs, we are wild. We want to find small mistakes to get it wrong, like mark you down. So pay attention. Okay, so we said x with sine. So x with sine, but there is no minus with the y squared. So this is out. Let's come here. X with sine. No, this is also out because x is going with the sine. Let's come here. This is also out. So definitely, without even looking at it, I know that the answer should be this, but let me check it. X, y, minus. Great. So the answer will be D. But we are going to use those answers to work here. So we are going to add question 5 and then 1 over r times question 6. So let me just copy question 6 here and send it down there. So partial of z. So you see how advanced is nice. It's very, very nice. Let's send this guy down there. Great. So now I'm going to multiply this by 1 over r squared. And when I do that, look at what is going to happen here. I'm going to multiply this one by 1 over r squared. Now, when I multiply this one by 1 over r squared, it will cancel this r. So this r will just go away, right? Great. So this will go away. This r squared too will go away because it's multiplied by r squared. And then I have another r squared here, which is also going to go away. So this is what I'm going to have. Then we are going to add this one to what we had for this one. So let's go to question 5 and go and bring that guy down there. What did we get for that guy? Okay, we had this for that guy. What was that guy? Okay. Partial of z with respect to r all squared. So let me just copy it so that I can move very fast. Copy. Let's go and do copy and paste. Somebody's asking, so how am I going to do copy and paste? Your book is folded, so you can unfold it and go to the next page. So what we are going to do is now we are going to add this guy and this guy. So this is what is going to happen. Partial of z with respect to r, all squared plus 1 over r squared. Partial of z with respect to y. This one's supposed to be x. I think so. Oh, it's supposed to be x. No, it's supposed to be r. And this one's supposed to be theta. Yes. Yeah. So now let's try and add. Now look at what is happening here. You see that this term here is the same as this term here, right? So we don't need to even write it. It's just going to cancel out. So this term, when I add this term and this term, will just gets to 0. Now what is going to happen here? Something beautiful is going to happen. Now this plus this, what are we going to get? Okay, let's see. I want to do something here. See, this term here and this term here are the same, so I can factor it out, right? So I'm going to have partial of z with respect to x, all squared out, and to be left with sine squared theta plus cos squared theta. I hope you are not lost, right? We are adding, right? And this out. This and this are the same, right? So I can factor it out. When I add them, I'll have this plus this. And since this and this are the same, I can factor it out and have this. Great. Good that you are not lost. Okay, let's look at this term too. This term and this term is also the same, so I can factor it out and it will be left with this and that. Great. I appreciate you that you are not lost. Great. So now this is going to be cos squared theta plus sine squared theta left. But remember the trig identity. When I add this, I'm going to get 1. This is also going to give me 1. So this is going to be partial of z divided by x plus partial of z divided by y. That's the reason why I love advanced so much. Like, it's nice, right? Great. It's nice when you understand it. That's the idea. So this is going to give us a. Okay, let's get to question 8. Okay, what is happening at question 8? Okay, this is going to be chain rule. Of course, we need to do that. So we have u, which depends on x and y. And we have v, which depends on also x and y. But what I'm going to do here is I'm going to let f of x squared minus y squared xy to be the same as uv. Why? Because this is v and this is u and this is v. So let's use the chain rule. I love drawing the diagram because it makes life very, very simple. Why? Because as soon as I draw my diagram, everything is done. Like, everything is done. So we see that this f here depends on u and depends on v. And v depends on x and y. And this depends on x and also depends on y. So now let's go to the question. Question wants us to find partial of f with respect to y. And I just look at my diagram and say, okay, I have y here, I have y here. So I need to go this way, I need to go this way and that way. Very simple, right? Yeah. So let's do this way, that way. So partial of f, we're going with u, and u will bring us x, right? So f with u and u will bring us y, plus now f will go with v and v will bring us the y. So f goes with v and brings us y. Great. Now because of this guy here, we can do something beautiful. Let's do something beautiful. We need partial of u with respect to x. So this is going to give us 2x. This one will be 0 because we are taking the partial derivative. Partial of u with respect to y is going to give us minus 1. Its partial derivative, this will be 0. When I differentiate this, I get minus 1. Let's get with v. Let me use different color, right? Partial of v with respect to x is going to give us y, and partial of v with respect to y will give us x. What do we need? We need partial of, oops, this one should be, okay, that's right. We need this guy and we need this guy. So this is going to give us, oh, don't forget that, when you have something like this, f of uv, we assume that this is coming first and this is coming last. So this is 1 and this is 2, right? So that now if I take partial, this partial here, because u is 1, I can write this one as f1, right? Because u is 1. So when you see f1, it means that we are differentiating with respect to the first variable. Great. And then this guy here is u with respect to y is minus 1. Is that right? Yeah, I think so. My answer is not going to match. Okay, let's see what's going to happen. What am I doing? Okay. Oops. This one's supposed to be squared, you know. Thank you. That's, I saw it. This is squared, right? It's here. Because just looking at this and minus is not good. So this is going to give us minus 2y. Great. So this is going to be minus 2y. Nice that we found out. And then this one we are differentiating partially with respect to the second variable. So I can write this one as f2. And this is times partial, this one is x. Is that right? Partial of this with respect to x. Let me check. It's like, no, I don't trust myself. Okay, I trust myself now. Okay, so this is going to give us minus 2y f1. But remember, f depends on u and v, so I can write this one to as uv plus x f2. F depends on u and v. So let's go through the solution. Oh, I'm seeing x instead of y. Why? Why is this happening to me? Am I doing something wrong here? Okay, let's find out. I'm taking partial derivative with respect to x, I get this. With respect to y, I get that. So it's either a typing mistake or, I don't know. Let me check question 9 and see. Question 10 and see. Okay. So let's change this one to y. So all the x here should be y. Okay. Great. So that now we can now look for the result. So we need minus 2y f1, which is here and which is also here. But we need plus x f2. So this is going to be b. Right. So our answer will be b. Great. I hope I did things right. Yes. So it's not supposed to be x. Okay. Now let's go to this question. So this question here wants us to differentiate what we did above. We already have this and we want to differentiate now along with respect to x. So assuming you are getting this one wrong, it means that the next one too, we are going to get it wrong, of course. So now I'm going to show you something beautiful that is going to happen down there. Now let's see what is going to happen down there. Let me just write this one and send it down there. Let's move this guy down there because that's what we need. Copy. Okay, let's paste it here. Oh, today is going to be a crazy day. We are just at question 9. We have 70 questions. I'm even exhausted. Let's see what God can do. Okay, so now let's see what we can do here. So here we just need to now differentiate this with respect to x. So differentiate with respect to x. Meaning that this will be partial of x and this will be minus 2y f1 plus x2. So look at what is happening here. This is just, this is just x. No, this is just y. It has no depends on this. So this is just constant. So we just need to differentiate this. So this is what's going to happen. This is the same as partial of x minus 2y f1 plus partial of x f2. So since this is a constant and it's not y, this is the same as minus 2y partial of f1 with respect to x. Plus, now this f depends on x because this f here, f2 depends on u and x, and u and x depends on x. So this is we are going to use the product rule for this. So this one, I'll maintain x and differentiate f2. Plus now I will maintain f2 and differentiate x. Quite interesting, right? of course. I hope you're enjoying it. Okay. So now what are we going to do? Let's check if we have the results there. So I can see this guy here, here too, also here, but this is out. Okay, let's see this guy. Do you have this guy? Okay, I can see this guy here. This guy is out, and also here. So now the option is left with A and B. Now let's look at this and this, this and that. What is happening? Okay, yeah. Okay, now I understand. When I take partial of x with respect to x, this is going to be 1. So this is going to be just plus 2 f2. So yeah, the answer will be A here. Great. That is beautiful. So it means that, yes, indeed, this one is supposed to be y, right? Good, because it helped us to get the results from question 9. Now, partial of x with respect to this is going to give us, so we want to go to x, so this is going to give us partial of f1 with respect to u times partial of u with respect to x plus partial of f1 with respect to v times partial of v with respect to x. So what is happening here is when I draw my tree now is f1, right? Like f1, which depends on uv, but we know that u and v depends on, f depends on u and v, and u and v depends on x and y. Great. So if I want to differentiate this f with respect to x, then first I'm here, I go to u, and then from u I get to x, right? So instead of making this one f, now it becomes f1, right? And if I want to get to x here, I pass to v and I pass to x. So that's basically what is going to happen. Now look at what is here. Remember, I told you that u is 1. So we are differentiating this one twice with respect to u. So this is the same as f11, right? Because don't forget, f1 is the same as partial of f with respect to u. So what I have here is the same as you writing something like partial of u with respect to partial of u. So you see what is happening here. So I have this with f1. What is this? So we are going with respect to u 2 times. So it means that this is going to be something like this. This is the same as partial of 2 divided by partial of u squared. And this one that I have here is the same as f11. Great. Times, what is partial of u with respect to x? Let's go and figure it out. Partial of u with respect to x is 2x. Partial of u with respect to x, when I differentiate this with respect to x, I get 2x. So I'm going to have 2x plus, now this, guess what? This is going to be partial of, this is the same as f of 1, 2. Why? Because this one here means that I have partial of v, but remember f1 is the same as this. So this is going to be partial of f, partial of u, right? So this, they are not the same, so we cannot write it this way. So what is going to happen here is, this is f1, right? Then I would differentiate with respect to v. So it comes again with f2 because v is 2. So that's what we are going to get. And v with respect to x, what did we get? V with respect to x, we had y. So we are going to get y from there. So this is going to be times y. Great. So which one are we going to get? Okay, let me just simplify this and have 2x f11 plus y f12. So 2x, this guy is out. Okay, f11, f11, f11. Now this is plus, this is out. So it's on this, and this is y. So it's going to be c. You see, it's nice, right? It's very interesting. I love it. Now let's do this with respect to that. So same again now, instead of F1, this is going to be F2, UV, UV. I hope you are enjoying the diagrams. Very simple, right? Great. So X and Y. Now this is going to give us, so because I want to go with X, UX, VX. So this is going to give us partial with respect to X, F2 of U, V. Now this is going to be partial of F2 with respect to U, UX, partial of F2, V, VX. Nice. So let's try and see what is going to happen here. Now remember, this is 2. So if I have 2 and I differentiate it by 1, remember VU is 1. So this is going to give us F2 okay, I think I need to erase this. So if I have F2, so F2 and I'm differentiating with 1, which is V, which is U, I'm going to have F1. Oh, why? Why this happening? I'm going to have 1. Great. Now, what is U with respect to X? U with respect to X. Let's go back. U with respect to X is 2X. And then this one is Y. So remember 2X and Y. Great. We don't want to go back again. So this is times 2X plus, now this is F2. My pencil is not okay. Now F2, remember V is 2. So this is going to give us 2. And remember this is Y. So this is going to give us 2X F1 plus Y F2 2. So we have 2X here. We don't have minus, so this is out. We don't have X2 here, so this is also out. We have X2, X2. We have 2, 1, 2, 1, which is this, but we want this one. D. Let's go. Let's go. Let's go. Let's go. Using your answer in 8 to 11. This is amazing. Wow. Okay. This is going to be crazy. Okay. Let's try and do it. So now we have this guy, X, Y of F of U, V. Now when you see this, this is the same as partial of Y and partial of, okay, this one should be X and partial of Y, F, right? Now, have we done something like this before? I think so, partial of F with respect to Y. Let's go and check it out. If we've done something, oh yes, no, not here. Oh yes, we've done something like that. So just copy this guy. No stress. Let's just copy this guy and go and use it. So what are we? We are here. So we've done this guy already, right? So what we just need to do is now is going to give us this with respect to X, and this which is here, now we are going to replace it by this. So this is going to give us duplicate and have this. So now let's try and differentiate this. Let's try and differentiate this. Now with respect to X. I feel like we've done this. Oh, okay. Maybe we've not done that. So let's see what is going to happen here. Okay. So this is going to be, I feel like we've done this. Partial square. Okay, let's do it and see what is going to happen. So this is now going to be, so I'm going to differentiate this with respect to X. So I'm going to have minus 2y out partial of F1 with respect to X, because this is a constant with respect to X. So this becomes constant. So I need to just differentiate this. Then I use the product rule here. I feel like I've done this. So I maintain X and differentiate F2 with respect to X times plus I maintain F2 and differentiate X with respect to X. I feel like I've done this. I feel it. Okay. Oh, I'm not doing things right. Okay, let's see. Let's see what's going to happen here. So when I want to differentiate this, let me just go up, up, up. I feel like I've done this. Yes, I feel like I've done this. Yes, this is the same as what we are doing, because this should be the same as this f with respect to x and y. I feel like that. So maybe the question, that's not what the question is requesting us to do, because if that's what it's requesting us to do, we have already done this. Okay, let me think about what to do here. Oh, I see. Okay, so let's try and do substitution. We have this, right? We have this. So let's just come and substitute them and see. We have partial of f1 with respect to x. That's why it's saying that we should use 8 to 11. So let's go and look for partial of f1 with respect to x. Partial of f1 with respect to x. That's this guy. And what did we get? Okay, we had this. So let me just send this one down there. Copy it. Let's do transfer. Oh, and advance is crazy, you know? It's very, very crazy. So it means that I'm going to have, since this is going to be this is going to be minus 2y minus, no, this is 2x f11 plus y f12 plus x. And then we've done this one too. With respect to x was just, I think, the one that we just did here, this one. And we had this. Let's send this guy to down there. So let's paste it here and have it. So this is going to be 2. Oops. Where did he go? Come here. Oops. Oh, where did he go? Okay. Let me just look at it here. Okay, I think I just did copy and paste, right? I can copy and paste again. Okay, good. So we have it here. X f21 plus y f22 plus f2, because this is going to give us 1. Okay, so let's try and expand this and see what we are going to get. So advanced is like you need to practice. If not, you're gonna die. You know, I don't mean you are going to die, you know. Okay, so 4xy and then minus 2y squared f1 2 plus 2x squared f21 plus xy f22 plus f2. And the question is saying that what the question says, I saw something here. F1 is the same as F2, right? So we are going to do that. So if F1 is the same as F2, then what are going to happen? Let me see the options. Okay. So we have this one here. What is this? Okay, so I think this one is supposed to be F21 should be the same as F. Good. So this is what the question is saying here. I think typing mistake here. This should be F21 should be the same as F12. Yes, that's what he's trying to say. So because they are the same, we can have this and this to be the same. So this can be written as F2 minus 4xy F11. So F2 minus this, and then this and this. So let me write this one again, plus xy F22. Then this is the same as this. So I'm going to replace one of them. Which one did they use in the solution? They use the 1, 2, because 1, 2 is the same as 2, 1. So this, we are going to write it as plus. So we are assuming that this is also the same as F12. So if they are the same, then we can add them. So this is going to be minus 2y squared f12 plus 2x squared f12. So finally, f2 minus 4x y f11 plus xy f22 minus, oops, I can do plus f12 out and have minus 2y squared plus 2x squared. Yeah, not bad. Let's check it out. So we have this guy running through, which is good. The one with 1 is minus 4xy. So minus 4xy. So this is out. Let's take this guy out. So the rest is true. And then the one with 2 is just xy but positive. So this guy too is out because it's minus already. So xy is good. So the answer is now between it's between here and here. So this is x squared minus y squared and minus x squared minus y squared and positive. So let's go and manipulate our solution here. Okay, so I can here I can do like I can factor 2 out, right? And I'm going to have 2 out. And when I factor 2 out, here will be left with x squared. Nice. X squared. And here will be left with minus y squared. So I'm going to have minus y squared. And then I have f12. So it's the one which is positive. So it's going to be A, right? Great. Nice. So objectives sometimes. So you see, we use just one question. We did from question 8 to 11, just one question, just one preamble. So think about it. You get right. Now let's look at this. We want to differentiate x with respect to u, v, and w. Okay, nice. So x with respect to u. Now this is x. We want to go with respect to u. So it's just going to be 1. X with respect to v is going to be minus 1. And x with respect to w is going to be 1. So we just differentiate this with respect to u. This become constant. So they will be left with this. Going to be 1. If I want to differentiate x with respect to v, this will be 0, this will be 0. And when I differentiate this, I get minus 1. And finally, with w or omega, this will be 0 and it will be left with 1. So it's going to be 1 minus 1, 1, which is this. So the answer should be A. Great. Let's look at 14. 14, we are going with y. So let me just do it here. Then we're going to do the answer. So we are going with y. So y with respect to v is going to give us 2u with respect to u, sorry. And then y with respect to v is going to give us minus 2v. And y with respect to w is going to give us minus 2w. So we need 2u minus minus. Okay. 2u minus minus. So it's going to be d, right? Remember, we have 2u minus minus. And finally, we need z. Okay, let's do z. So it's using the same thing here. So with z, partial of z with respect to u is going to give us 3u squared. And partial of z with respect to v is going to give us 1. And partial of z with respect to w is going to be given as 0 because we don't have this one. So remember, 3u squared and 1 and 0. 3u squared, 3u squared, 1 and 0. Great. So we choose B. We have more questions to do. Oh my God, this question is amazing. Now let's look at this question. We want to find limit of this, but we need some strategy, right? Absolute of x, y. Now this is a magnitude, so this is the same as x squared plus y squared. So it means that the question that is given is limit square root of x squared plus y squared is approaching, oops, we didn't bring this one. This should be approaching infinity. I think so. So this should be limit absolute of x, y approaching infinity sine of x squared y squared divided by x squared plus y squared. Great. So it means that this will be x approaching infinity sine x squared y squared divided by x squared. Now, trick. Anytime I see a question which goes with x squared, y squared, I need to think about polar coordinate. Yes, it's something that we need to use. We are going to use it a lot. So polar coordinate is, this is my x, this is my y, and this is my r. So using Pythagoras theory, x squared plus y squared is equal to r squared. So it means that I can replace this guy by r, this guy by r. But I need x squared, I need y squared. What can we do? So we are going to do something amazing, right? Great. Now let's see. I can also use trig to find out that x is equal to r sine theta. How did I see this? Now remember that sine theta, if I want to find sine theta here, it's, let me put here and put the angle here. It's, let me say opposite over hypotenuse. So this is going to be x over r, and making s the subject is going to give us this, right? Great. Or x should be going with a cos rather. Yeah, I think x goes with a cos. Okay, yes. You know, this is y-axis and this is x-axis, of course. So this one should be cos. Yeah. And this is going to be cos theta. So cos theta is equal to adjacent over hypotenuse. So we are going to have this. And y is going to be r sine theta, right? Because it's going to be sine theta, which is equal to opposite over this. We have this. So when I square this, when I square x squared, I'm going to have r squared cos theta squared. And when I square this one too, I'm going to have sine squared theta. So that's what I'm going to get from this. So now let's try and plug them in, right? So what is going to happen here? All right. So now if I want x squared plus y squared, this is going to be, okay, we've done x squared, r squared. S squared, y squared is already this. So this one means that r is equal to square root of x squared plus y squared. So here I'm going to have limit as r is approaching infinity. So that's one thing that I'm going to get from here, because this is the same as r. Now x squared times y squared, I'm just going to multiply this and that. And this is going to give me sine of r to the power 4 cos squared theta sine squared theta divided by, now this is r squared. So that's what I'm going to get here. So this is going to give me r squared. This is nice. Now, for us to solve this, we need to use squeeze theorem. Why? Because we have sine here. So we know that sine is bounded by 1 and minus 1. So it means that what I have here is going to be bounded by minus 1 and 1. Sine squared theta, right? No matter the angle, is going to be bounded by that. Now I want to form what is here. Now this is divided by r squared. So I need to divide through by r squared, and I'm going to have minus 1 over r squared less than or equal to r to the power 4 squared theta sine squared theta divided by r squared less than 1 over r squared. So what I'm going to do is, I've gotten what is here, which is the same as this, but this is attached with limit as x is approaching infinity. So I'll do limit as s approaching infinity here, this one and this one. I don't want to write because I think the questions are a lot. So I'll just write this. R is approaching infinity, 1 over that squared less than r is approaching infinity, 1 over r squared. Now when I plug in infinity here, 1 divided by a very big number is going to be 0, and 1 divided by a big number 2 is going to be 0. So this is 0, this is 0. Based on the squeeze theorem, this should be given as 0. So we should be getting our answer to be D here. Very nice. Now let's look at question 17. Oh, nice. Question 17, we want to use the limit definition to do this. Or we can also differentiate it, right? So let's look at what we can do here. Now we need f of 1 of x, y at where x and y is never 0. So looking at the function is 0 when this, okay, this is wrong. This is a typo. So this should be equal to 0, 0, right? So this is where the point should be. So when x and y is 0, 0, we have the function to be this. And when it is not equal to 0, we have the function to be this. So at this stage, our f of x, y is the same as x squared minus xy divided by x plus y. Great. We need f1. F1 means that, look at the function here. We have x and y. So this first variable here is 1 and this is 2. So it means that this that we have here is partial of f with respect to x. So that's what we need here. So this is the same as partial of x, but this f here is this. So we are going to have x squared minus xy divided by x plus y. Now this we can use the quotient rule. Quotient rule, I'll set the top to be u and the down to be v. So my u is equal to x squared minus xy, and my v is equal to x plus y. Now don't forget we are differentiating with respect to x. So my partial of u, this is going to be u1 or ux because it's with respect to x. So let me use 1 because we are using 1. Okay, let me use x so that you know what we are doing here. But don't forget this is the same as u1. So with respect to x, when I differentiate x squared, I get 2x. Now y is constant, and when I differentiate x, I get 1. So this is minus y. Vx is the same as v1, and this is going to be just 1. So what is the quotient rule? All right. Quotient rule says that if I want to differentiate this function, okay, let me just pick this one up to this one, duplicate it, and bring it. So if I want to differentiate this, quotient says that maintain Vn differentiate u minus maintain u differentiate Vn divided by Vn squared. So let's do substitution. Vn is x plus y times, okay, so this is partial, right? So the x should be here, sorry. Good. So this is going to be 2x minus y minus u is x squared minus xy times Vn x is 1 divided by Vn squared, which is this. But before we simplify, we need to look at the options before we simplify. Okay, so we just need to simplify the top. We don't need to simplify the down. Okay, so let's try and do this. When you multiply this by this and this, you are going to have 2x squared minus xy. Then we'll multiply this one by this and this. This is going to be plus 2xy minus y squared minus x squared plus xy. So here I multiply 2 by the minus, and this is going to give us x plus y all squared. Now finally, let's see. I have x squared here, I have x squared here. So this is going to give us something beautiful. Somebody's saying that maybe everything is beautiful. Yes, everything is beautiful, you know. So this minus this is this. And then this guy here, this guy here, and this guy here is going to be cool. So this and this is going to be 3xy. Subtract this, or let me say this will cancel this and it will be left with this. So plus 2xy minus y squared divided by x plus y squared. So let's go and check. Remember, this is a minus. The rest are all positive. So we have this, 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 this. There is no minus, so this is out. There is 2 minus, this is out. There's 2 minus, so the answer will be this, this. Because it's basically this one here. The y squared is minus here. Great, so we had B. Let's use this to do the 18. So the question is saying that, okay, what is this at 1? So it's saying that f prime of minus 1 is this. Let's find f of 1, 2. This is going to be amazing. So what we can do here is using the limit definition. So let's use the limit definition. f1 of 2. Now f1 or 2, think about this function. Like this is the same as limit. Now because we are working with a 2, this one here is k, right? So I'm going to use k is approaching 0, and f1 of, okay, let me put this one here. Remember we are finding of 0, 0, but let's do of xy first. So this is going to be x y plus k. Why? Because the change is on the 2, right? We are on this one because we have f1 already. What is f1? This is f1 because that's what we found here. This is f1. Great. So we are focusing on the 2. Let me just underline it. We are going to focus on the 2. So everything is on the 2. On the 2 is y. Pay attention to that. So I have k is approaching 0. So since the 2 is on the y, if I erase this one, it will be left with f1. So this one should be f1. Then the change will be on the y, and this will be minus f1 of xy divided by k. Is that right? Yes, of course. So now we need f of 1, 2 of 0, 0. So this is going to be a limit. K is approaching 0 of f1 of 0. And when I plug in 0 here, this one will be left with just k minus f1 of 0, 0 divided by k. But thank God we have this guy, which is here, which is minus 1. So we need this guy. But f1 is given to be this. So let's just lift this guy, copy it, and just place it here. So what is going to happen here is, now don't forget this guy here is xy, and we need f of 1, 0k. So we just do substitution. So this is going to be 0 squared plus 2 times 0 times k minus k squared divided by 0 plus k all squared. Simplify. This will be 0, this will be 0, left with minus k squared divided by k squared, and this is going to give us a minus 1. So let's do substitution now. This is going to be limit k is approaching 0, and this is minus 1. So we are going to have minus 1 minus, okay, this is also minus 1. So we are going to have minus 1 divided by k. And this is limit k is approaching 0. And this is minus 1 plus 1 divided by k. And this is 0 over k. I love doing step by step, right? And this is going to be limit k is approaching 0 of 0, and this is going to be 0. Please, when you are solving, don't go through step by step like the way I'm doing it, because I just want you to understand the workings, but jump some steps. You can, sometimes you can use your eyes to do it, but if you are very fast too, you should be able to use step by step, because sometimes it's like you know that you are doing the right thing, but maybe your mind will just play around and you get it wrong. Now let's see this. I love drawing. I have f of u. Now this f of u, which is u, okay, I have u, right? I have u. U is the same as f of v, right? So let's see. But v depends on, okay, so let me do it this way. U is the same as f of v, yes? And this guy depends on v, right? This one here depends on v. So this one depends on v. And v depends on w, x, y. So we are going to have 3 of them. X, let me just do it, x, y, w. And then w depends on z. So this w guy just depends on z. And x depends on t and z. So this guy depends on t and depends on z. So let me stretch this one down small. And y depends on t and z. So y is also depends on t and also depends on z. Such a something. This is beautiful. Now we want to find partial of y with respect to x. Wow, this is going to be so amazing. Let's find out what we are going to get here. Now we are going to go through the change rule from this up to down here. So let's see what is going to happen. We are starting from u. Okay, I think this one is supposed to be u. I think so. Okay, let's see. Let's see what is going to happen, because I think this should be partial of u with respect to x, right? So that we move from this up to down here. But let's see. Because if I want to be on y, then this is not going to be good. But let me just assume that it's this one, and let's see if you are going to get it from the option. Then it means that it's wrong typing. So if I want to get to u, I need to pass through v. Oh, so it means that this is not true, because we cannot go v and go up. Okay, let me just pause this question here. I'll come back to it. Question 19. Maybe don't forget question 19. We'll get to question 19. I don't want to wait too much time thinking about something. Okay, let's use the limit definition to do this. Now, when you see f of y, this is the same as y2, f of 2, because this is 1 and this is 2. So this means that we need to use the limit definition. So what are we going to do? This is going to be limit k is approaching 0, and we have f of xy minus, oops, the change is on y. So let's add the change to y, and xy divided by k. So please remember how to write the definitions. It's very important. Now we need this point. So this is going to be, don't forget, this is x, y. So f2 of 3, 1 is going to be limit k is approaching 0, f of 1, oops, f of 3, 1 plus k minus f of 1, f of 3, 1 divided by k. So we just need to expand the top, and then we are done. So now let's look for f of xy is equal to x squared minus 3xy plus y squared. So let me look for f of 3, 1 first, so that it can help me to eliminate some of the options. I can do even this, and then I will get the option. So 3, 1 plus 1 squared. So this is going to be 9 minus 9 plus 1, and this is going to be 1. Okay, they simplify it, so still we don't have any choice but working it out. So now let's look for f of 3 and then 1 plus k. This is going to be 3 squared minus 3 times 1 plus k plus 1 plus k squared. So this is 9 minus 9 times 1 plus k plus 1 plus k, 1 plus k. This is the same as 9 minus 9 minus 9k plus, expand this, we have 1 plus 2k plus k squared. Now these guys will just go away, and we are going to have k squared. When I add this one to this, I have minus 7 minus 7k plus 1. Great, so everything is set. Let's just go and substitute it inside. So this is limit k is approaching 0. Then this guy here, we had k squared minus 7k plus 1. K squared minus 7k plus 1. And this is 1. So it's going to be minus 1 divided by k. This is limit k is approaching 0. This will cancel this. So we are going to have k squared minus 7k divided by k. We can factor k out and cancel, but I'm not sure that's what they did in the option. So let's look at what is going to happen. This is very tricky. Okay, the answer is D. You see, so this one, when I swap k squared and this one, I have minus 7k plus k. So advanced calculus for you. Always different, way of doing it. Okay, I think this one we've not done it, but harmonic functions of two variables satisfy the Laplace equation. So that was just watch and write. Okay, let me see. I think I need to start giving you some of the questions to solve. So let me show you how to do this. We need to find partial of z with respect to x and respect to y. So do this, leave your answer in the comment section, right? So partial of z with respect to x, let me just do one. Now, one thing that you need to remember is when you are taking the partials, other things becomes constant. So here, if I'm differentiating this I can factor 4y out. When I factor, so this xy, this is the same as 4 over y times 1 over x. So I'm just focusing on differentiating this. And this 1 over x is the same as x to the power minus 1. So when I differentiate this using the power rule, this is minus 2. And this is going to be the same as minus 1 over x squared. So this is going to give us minus 4 over yx squared. Or I can bring x first and have x squared y. So this one, you should be very good with derivatives, kind of like you know what you are basically doing it. So you see what I did, because I'm differentiating with respect to x, this is constant, so I factored this one out and then just differentiated 1 over x. But 1 over x is the same as this. Using the power rule, I have it to be this, and then I have this. So now I multiply this by just the constant here, and I'm going to have this. Then you differentiate this one with respect to x. Now remember, x over y is the same as 1 over y times x. Y is constant, so I need to differentiate this, and I get 1. So this is just going to be minus 1 over y. So this one is true, this one is not true, this one is not true, this one is true. So we have eliminated b and c. So it means that now differentiate z with respect to y and to get this here. So with respect to y, I see it directs that, this is basically the same as this. So the first one should be minus 4 divided by xy squared. Something like that. Is that true? Yes, that should be true. Yes. And then minus, no, this one will be plus xy squared. So the answer should be this. Great, I had it right there. So what did I differentiate this? I just took my time and said, okay, since I'm going with respect to y, now 4 over x is constant, so I just need to differentiate 1 over y squared. So this 1 over y is the same as this. Using the power rule, I have minus y minus 2. And this is the same as minus 1 over y squared. Then I used to multiply. So I'm just going to have minus over y squared here. And when I multiply, I'm going to have what is here. Then I have minus x over y. Now, minus x is constant, so I just need to differentiate this. And when we differentiated this guy, we had this. So when I multiply, I'm going to have minus x times 1 over y squared minus, and this will be x over y squared, which is also this. So advanced, you should be very good with derivatives, right? And how to treat other functions like constant. So I want you to do this. Now, this one, you are going to use what is here, right? We are going to use what's here. Now, for us to do this, you need to use the change rule, because now we are going with respect to x and this one, but we need to compute the product. So the product means that I differentiate this. When I finish, I multiply by this one. Very simple. So you go with respect to x. We've done it already, which we had this. And then now we go with x with respect to u. So x with respect to u is going to give us just 2u. Okay, let me just do them very fast. X with respect to u is going to give us 2u. And then this guy with respect to x, we had minus 4 over x squared y plus, is it plus or minus 1 over y. Then what happened? We just need to substitute this guys in, and then we just do it. So I will leave it for you to do it. So do the rest, okay? Compute them and then just do it. So do 23, finish 23, finish 24, finish 25, and finish. Okay, that's all. So I want to expect 23, 24, 25 in the comment section. Let me see if we are getting it right. Let's get here. Okay, let's use this one to find, we are going to use to solve for 26 and 27. We need partial of x. But don't forget, f is equal to x, y, z. It means that x depends on y, depends on z. Oh, this is going to be amazing. You know? Now, since we are going to differentiate with respect to x, everything is constant. So everything on the top here is constant. So think about this like you have, what am I going to even say? Think about this one like you have x to the power u, where u is equal to y to the power z. Now, if I want to differentiate this using the power rule, this is going to be u drops down times x to the power u minus 1. Right? So that's basically what is going to happen. But my u is equal to this. So I just replace it and I have this times x to the power yz minus 1. So pay attention well. So what should be the results? Okay. I think this is better choice. I have y to the power z and then y to the power z minus 1. Yeah, so drop this one and subtract 1. That's all that we have to do. Now we want to go with respect to y. Now with respect to y is now on different level. X, y, z. This is on different level. This, you are thinking about this like you have 2 to the power y. Oh, let me see. What am I going to say? What am I going to say? Okay. Like, okay, look at this like you have 2 to the power x and you want to differentiate. Now remember, if I want to differentiate this, f prime is going to be, I'll differentiate what is on the top here. But because I'm differentiating with respect to x, I need to differentiate what is on the top here. So this is going to be differentiate x, get 1, maintain the function, and take ln of the base. Great. So that's basically what is going to happen. Okay, I think I need to do something nice here. Let me make this guy u so that it will be fine. So this will be u prime. Good. And this is going to be u. So if I want to differentiate something, because of where the y is, so u prime times the whole of the function times ln of the base. So let's compare this. When I see this, I see that 2 is equal to x. And u is equal to y to the power this guy here. Nice. So what is going to happen here is we need u prime. So what will be u prime here? Now this guy is constant. So you are thinking about this like you are having y to the power 2 or y to the power 10. So u prime will be equal to z down y to the power z minus 1. So now let's do substitution so that we get fy. So we need u prime. U prime is giving us z y to the power z minus 1 times the whole function times 2 to the power u, but 2 is x, so I have x here, and u is this, which is yz, times ln of the base, which is 2, but this is going to be x. Nice. So what happens here? I just took what is on the top and differentiated, right? So when I differentiate what is on the top here, I get this. Maintain the whole function and take the ln of the base. So let's go and see what is going to be here. I have z here. I have yz minus 1. I have the function, I have this. So this is going to be the, of course, 27. Now let's look at this function here. We have, a function that is, we are approaching 0, 0. I want to see what we can do with this. So let's go through this. Right. Let's go through this. So this, we can use iterated limit to find out if this is going to work. So what I'm going to do is I'm going to pick limit as x is approaching 0. Then I go with limit x is approaching, y is approaching 0 of the function. So let me assume that this is f of xy, right? Of f of xy. So first I plug in 0 inside the y. So let's do that. What is going to happen? Limit x is approaching 0. Plug in 0 for y. So when I plug in 0 here, this will be 0. So it will be left with 2x all squared divided by, when I plug in y, everything with y will go away. So it will be left with x squared. Now let's simplify before you plug in 0. So this is 4x squared divided by x squared. And this is limit x is approaching 0 of 4. And this is going to give us 4. Now let's swap it and go with respect to y first. Y, and then this is going to be x of x, y. So this is going to be limit y is approaching 0. Now plug in 0 first. So when I plug in 0, here will be 0. So it's going to be left with y squared divided by 0, 0. This is going to be 3y squared. So 3y squared. And this is limit y is approaching 0. Y squared will cancel y squared. So it'll be left with 1 over y, 1 over 3. And this is 1 over 3. So you see that automatically going this way before this way, they are not the same. So here we are going to just say that the limit does not exist. We are done with that. Now let's look at this one too here. So as I said, anytime you see limit as x is approaching something, and you see that the function given to you is of the form of like x squared plus y squared, we need to think about the polar coordinate. So let's do that again with polar coordinate. So theta here, I have my theta here, r, and this one should be y, and this one should be x. So Pythagoras theory, r squared plus x squared plus y squared is equal to r squared. It means that r is equal to square root of x squared plus y squared. So it means that here we are going to have limit r is approaching infinity. Now what is x squared plus, y squared? That one is r squared, right? So from here we have this. Now look at this one here. At the denominator, I can write it as x squared plus y squared divided by another x squared plus y squared again plus x. So I'm going to have another r squared plus, what is x? Okay, let's find x. Using the trig identity, this is cos of theta is equal to x over r. So x is equal to r cos theta. So it means that this is going to be r cos theta. Nice. So this is what you are going to get. Now let's try and then, do something here. Now we have reduced this one to this. Now I can factor r out and have r. And here I can factor r out and have r plus cos theta. So one of the r will cancel. So this is going to be, limit r is approaching infinity of r divided by r plus cos theta. So now what is going to happen here? Now, since x is approaching infinity with respect to r, I would like to divide 2 by r, the top by r and the down 2 by r. So I'm going to have r is approaching infinity. When I divide this one by r, I'm going to have 1. When I divide this one by r, I'm going to have 1 plus. Now, when I divide the last one, I'm going to have cos of theta divided by r. Great. Now here, if we fix theta and r is approaching infinity, we are going to have a small number divided by a very big number. So this is going to be 1 divided by 1 plus 0, because a small number divided by a big number is going to be 0, right? And this is going to give us 1 over 1, which is equal to 1. So we are going to have this one right here. Now, okay, this one is the partial definition. So I'll just leave this one for you to figure it out. What is the definition for this? Leave your answer in the comment section. Okay. Now, this one we want to find domain. Okay, great. Now, domain under the square root means that everything under the square root should be non-negative. So xy over x squared plus y squared should be greater than or equal to 0, right? But we need to do something to help us. I can write this one as square root of xy and then also square root of x squared plus y squared. So when I do that, now I have the function to be 2 terms. So now I can pick that down. Square root of x squared means that x plus y squared should be greater than 0. Now we said that under the square root, everything should be greater than or equal to 0. But because this is at the denominator, we cannot include 0, right? So it means that everything should be greater than 0. Of course, this one should be everything greater than 0. Now let's look at the top. The top, we can include 0. So xy should be greater than or equal to 0. So now what is happening here is, now if I include xy to be greater than or equal to 0, look at what is going to happen here. This one, it means that for the function, if x is 0 and y is 0, we can also get 0. So we don't want to get 0, because as soon as it's 0, when x is 0 and y is 0, the denominator will be 0, because 0, 0 will be 0. But one of them can be 0, right? One of them can be 0. But making one of them can be 0 can also affect this one here. So what is going to happen here is we are going to restrict x, y to be greater than 0. And since this is positive, since this is positive, we want to look at this. This implies that x squared is also greater than 0. And y squared is also greater than 0 from here. Because if x squared is greater than 0 and this one, when you add them, you get this. Now from here, I can see that, okay, it's indeed that x should not be 0, right? X is greater than 0 means that x, or I can say that x is also greater than 0. And here y is also greater than 0 from this ones that we have here. So it means that here we need to basically exclude the x is equal to 0 from the denominator. So now with this one, we are going to pick this and this. Great. So this is what we are going to choose here. We need to choose A, because x and y should be greater than 0. And x and y cannot be 0, because as soon as x and y is 0, the denominator will be undefined. So that is the analysis from there. Now let's look at this one too. This one we need f of 2xy. So 2 is y. Good. So we are going to have limit k is approaching 0, f of xy plus k minus f of xy divided by k. So what is going to happen here is we want to have f of 2, 0, 0. So this is limit x is approaching, k is approaching 0, f of 0 and k minus f of 0, 0 divided by k. But f of 0, 0 here is equal to 0. So the function will reduce to limit k is approaching 0, f of 0, k divided by k. So we just need f of 0, k. Now f of 0k here is where, that, so 0k is the same as x, y. And we can see that this is not the same as this because k is not 0. So the function that we are going to use will be this. So f of x, y is equal to x to the power 3 minus y to the power 3. I'm so exhausted, but I have energy. We can just finish this. Let's keep it on. So this is going to be 0 cubed minus k cubed minus 0 squared plus k squared. This is minus k cubed divided by, so you can see that I'm so tired. So you see the way I'm writing. Yes. So now this is going to give us limit k is approaching 0 minus k divided by k, and this is limit k is approaching 0 minus 1, and this is going to give us minus 1, and we have d. Okay, let's look at 29. Oh, nice. Definition. I love epsilon delta. Now, if given epsilon greater than 0 and delta depending on epsilon also greater than, such that when we pick, so this means that we are picking a point in the neighborhood. So this means that it should be uniform, right? Because we are going to pick, point from the neighborhood. It means that anytime the function is, let me say, uniformly continuous, it means that it's pointwise continuous, and it's going to give us the uniform continuous. So since it's pointwise continuous, then we can pick point from the neighborhood, right? Any point that we pick from the neighborhood is going to make it right. So this one is going to give us the uniform continuous. So always look at what is here. Since we are picking point from the domain, then this is indeed going to be the uniform. And this one, epsilon is greater than 0, but here delta depend on the point. So anytime that delta depend on the point, it means that, we cannot basically choose some points just randomly, right? Because it depends on this. So we have this and we have this. So since we can plug in f of a and b, the function should be continuous, right? So the function should be continuous at this. Because remember, a function is continuous when the limit exists, and we can also do direct substitution. So this is the direct substitution here, and the limit also exists here. Great. So that is basically the idea here. 31. We are almost getting there very soon. So 31, I'm going to also use iterated limit again. So I'm going to go limit as x is approaching 0 first, and then go to limit as x is approaching y of f of x, y, because this is the same as f of x, y. Just only this, the one in the parentheses. So when I plug in y, guess what we are going to get? Okay. When I plug in y is equal to 0, I'm going to have x squared divided by x squared. And this is limit x is approaching 0 of 1, and this is 1. Let's go with respect to y and with respect to x of f of x, y. I'm so tired. Oh, God. Help me. I need strength to finish this with my people. Okay, so this, when I plug in 0, I'm going to have 0 divided by 0 plus y squared. Right, this is supposed to be y. And this is limit y is approaching 0, and this is going to be 0. So they are not the same, right? 0 and 1 is not the same. So I'm choosing this. Let's keep moving. Oh, this is going to be too much. Too much. Now, one thing that we need to remember here is when I differentiate tan inverse of u, this is 1 divided by 1 plus u squared times u prime. So let's look at this guy here. Compare this to this. You can see that here our u is equal to y over x minus 1. And compare this one to this one, you see that our u is equal to u over y over x plus 1. Now we need partial of u with respect to x. So we want to differentiate this with respect to x. Great. So this one is going to be partial of this tan inverse of y over x minus 1 plus partial of x, tan inverse of x, y over x plus 1. This is going to be a lot to work with. But we are not scared. Why? Because we have the formula here. Since we know this, we are okay. So that's why we need u and we need u prime. So we can find u prime here. But this is partial. We need partial with respect to x. So this one we can use. I have a short strategy that I can use, but I don't know whether you are going to like it. But I can also use what is called quotient rule. So I can say u here, v here. Oh, I'm using u already. So a over b. What is a? A is y. What is b? B is x minus 1. What is a prime? Remember, this is not just a prime, ax. So this is y, so it will be 0, bx will be 1. Quotient rule is going to give us maintain b differentiate a minus maintain a differentiate b divided by b squared. So this is going to give us, a prime times b, or let me say ax, and then this will be x. So ax times b will be 0 because it's 0, minus a times this is going to give us just y divided by x minus 1 squared. So this is going to give us minus y divided by x minus 1 all squared. So that will be our ux in this side. So using the formula here, we are going to have 1 divided by 1 plus u is 1 y over x minus 1 all squared times minus y over x minus 1 all squared plus 1 divided by 1 plus y over x plus 1 all squared times, we need to differentiate this. But now, this one, x is positive. So if we are doing the same thing, this will just going to be positive. This will still be 1. And this is just going to be positive. And still, this is going to be minus there. So this is just going to be minus y divided by x plus 1 all squared. The rest is simplification. Oh, this one is too simplified. Okay, let's see what we can do here. This is the same as 1 divided by 1 plus y squared over x minus 1 all squared times minus y over x minus 1 all squared. Let me just do this one first. This is the same as, find the LCM. So this is going to be x minus 1 squared minus y squared divided by x minus 1 squared times minus y divided by x minus 1 all squared. Now, because of 1, we can reciprocate this to have x minus 1 squared divided by x minus 1 squared minus y squared times minus 1 over x minus 1 squared. So this guy can cancel this guy, and we are going to get something beautiful. What's that thing beautiful? Minus y divided by x minus 1 squared minus y squared. So we can follow the same procedure for this because it's just this which is positive. So when I do that, it means that let's see what is going to happen here. This is going to be plus minus y divided by x plus y squared minus y squared. I think so. Oh, is it supposed to be y squared or y? Okay, y squared. But something is going to happen here. I think this should be plus because when I do this, I'm going to have 1 plus y squared divided by x plus 1. Yeah, so this should be plus 2. Good, let's go and see it. We have minus minus. Okay, so if you are not minus, you are out of the equation. Everything is positive. Why? Okay, I think I need to watch this guy here. If we are using u here, this 0, so it's going to be still minus 1. This is great, but let's think about this guy correctly here. This is going to be that. You're going to have this one to be positive and this one to be positive. Okay, so let's check it out. So we have, let me write my final answer here. This is one thing I don't like about advanced. You have gotten the answer, but you can't see it. Advanced and further calculus are crazy. So x minus 1 squared minus y squared, great. Then minus y squared minus y divided by x plus 1 squared plus y squared. Okay, I know the trick. When I bring this minus down here, it will make this one minus and this one positive. I'm sure that's what they've done. So this is going to be y divided by y squared minus x minus 1 squared minus y divided by x plus 1 squared x plus 1 squared plus y squared. I'm sure that's what they've done. Sure, pretty sure. So the one with the minus here, no. This one to no. Okay, this one to no. Okay, I have this guy. Is it the same as this? This guy should be all positive. Let me see. Negative. All positive is this and this. But there is no negative here, which is not true. Okay, let me check. Oh, okay, this is minus. Okay, this is minus. Great. If that is minus, this should be minus. Oops, I'm so sorry. I'm so sorry. And because of minus here, minus will be positive. So this is minus minus. So this should be positive. Okay, fine. Now finally we are there. So it means that this all of them are out, because the one with positive is having minus y squared. So this is out. Now we have these people to be concerned with. Now look at this. We have x minus 1 minus. But there's minus up here, which we don't have. We have minus up here, but there is no minus here, which is so terrible. Very terrible. Okay. I don't like why I'm wasting too much time on this particular question, because it's not good to waste too much time. It means that this one shouldn't be minus. How? We don't have this one too. We have something here. Let me see, minus. But this one cannot be minus. Minus, all of them are plus? No. Minus. Okay, so this suits this, but this is making this one minus. So let me check it again. So since this is minus, I have minus will be positive. So there is no way I'm going to get minus anyway. Okay. So I don't know. Let's move on. I think we almost did it, but take time, and when you get the right results, just put it on the comment section, okay? And we need to find this one too. Oh, this one too is going to be terrible. Now, this one we need to go with respect to y. Okay, this is not terrible because this is very sweet. Okay, with respect to y, we have our u for the first one to be y divided by x minus 1. Maybe this one will help us to do that. And y over x plus 1. Let's see what it's going to be. Here, I need, with respect to y is on the top. So when I differentiate y, I just have this guy here, x minus 1. U of y here too is going to be 1 over x plus 1. So, partial of u with respect to y using the tangent function is going to be 1 divided by 1 plus u squared, which is going to be 1 y squared over 1 x minus 1. I think I'm tired. That's why I'm not seeing things stop. Times 1 over x minus 1 plus 1 over 1 plus y squared over x plus 1 all squared times 1 over x plus 1. Okay. So what is going to happen here? We know that I will just write this one straight, if you like. This is the same as x minus 1 squared plus y squared. Oh, okay. I think that's the reason why. Why did we get minus here? Look at what happened here. This is plus, and we were using minus here, so that is the reason why. This should be plus. So this will be plus. Oh, beautiful, beautiful, beautiful. So this guy is, let me just erase this, and this is positive. So the answer is here. Great. Sorry about the trouble, but I think, yeah, C is right. C is right. Now let's look at 33. Okay, so this really helped us to find out what is wrong, which is beautiful. So x minus 1 all squared times x minus 1 plus, so we can, when you are done, we can just do this one. So x minus 1 squared divided by x minus 1 squared plus y squared times 1 over x minus 1. One of them will cancel out, so we are going to have x minus 1 divided by x minus 1 squared plus y squared. And looking at what is here, this is going to give us plus x plus 1 divided by x plus 1 squared plus y squared. Yeah, so that's basically what you are going to get. So let's try and find out. So x minus 1, and then everything down here is minus. So this is out, x minus 1. This is true, but okay. Why am I keeping forgetting the minus? This one should be minus because of this minus here. I'm sorry that things are not going well because I'm thinking that I'm tired, but no way, we will finish this. So I think the answer should be C. No, it's not C because this is minus. Okay, let's look at this guy here and this guy. This one shouldn't be minus. Okay, so the answer should be B. Yes. That's one thing about advanced. It's complicated. It's so complicated. I don't like it. Oh, I said I love advanced. Sorry. I love advanced, please. I love advanced. You should be able to enjoy advanced. So let's look at this question here. All right. So this question, what is the best way to do this? Okay, the best way to do this is to find a conjugate, right? Because we have two square roots. So x squared minus square root of 1 minus y squared. Somebody is saying that I think we can use polar coordinate. Yes, let's use polar coordinate. But we can also find a conjugate. But let's try polar coordinate and see. No, polar coordinate is not going to work out. It's going to be so terrible because of the plus here. If it was minus, then it's going to be great. But let's use, let me just write what I did. Let's use x squared plus y squared. It's because of not x minus 1. If this one was 1 minus x squared, polar coordinate are going to be great. So I'm going to multiply this one by the conjugates. This will be positive divided by the same thing on the top. So let's do the multiplication when you are done. So when I multiply this by this, I'm just going to have 1 plus x squared. And when I multiply this one by this and multiply this one by this, minus positive go away. So I just need to multiply this and this. I'm going to have minus 1 minus y squared divided by x squared plus y squared. And I'm going to maintain square root of 1 plus x squared plus square root of 1 minus y squared. Let's simplify the top. When I simplify the top, I'm going to have 1 plus x squared minus 1 plus y squared. So this will cancel this. I'm going to have x squared plus y squared. And so on the top, we are just going to have this divided by x plus y squared, square root of 1 plus y squared, plus square root of 1 minus y squared. So what is going to happen is this guy will cancel this guy, and this is going to be incredible. This is just 1 plus x squared square root plus 1 minus y squared. Well, now we are taking limit as x and y is approaching 0. So let's do that. X, y is approaching 0, 0. So when you plug in 0, what happens? I plug in 0, I plug in 0. Nothing happens. So let's do that. 1 divided by square root of 1. 0 squared is 0 plus square root of 1. And this is 1 divided by 1 plus 1. And this is 1 over 2. Great. So as you are looking at this, you see that every question and the strategy, right, that we are going to use to do this. Oh, epsilon delta definition. So we need to know what to choose. Okay. So we, based on the epsilon delta definition, it's already here. If this is greater than this, there is this such that this is that, and this is this. So this is a continuous function. This is continuous. So you see that this depends on delta. So anytime you see a point like this, it means that the function is continuous. So now let's start by building this. So absolute of f of x y minus f of 1 2 absolute. This is the same as this guy here is this. So I'm going to have xy plus 6x minus, then I need to plug in 1 and 2 inside this. So let's just do it somewhere. 1 2. This is going to be 1 times 2 plus 6 times 1, which is equal to 2 plus 6, which is equal to 8. Okay, so this is going to give us 8. Now, one thing about this question is how to do the manipulation, right? But if you don't take care, you won't get the right thing. So this is what I'm going to do. For me, I'm going to choose x out and have y plus 6 minus 8. And because I need y minus 2, I'm going to add y plus 6 because of this guy. I'm going to add y plus 6 and subtract y plus 6. So I'm going to have x y plus 6 minus y plus 6 plus y plus 6 minus 8. So I just added this term, which is 0. So that now I can factor this and this out, right? So I'm going to have y plus 6 out, and it will be left with x minus 1. So you see what I'm doing here. So I factor this one out, it will be left with 1. Factor this one will be left with x. And this one here is y plus 6 minus 8 is going to give us plus y minus 2. So you see the way I build my y minus 2 and my x minus 1. So it's solving more questions that's going to help you to do this. So let's use the triangle inequality. This is the same as y plus 6 x minus 1 plus y minus 2. Now I can write this one as, this is the same as absolute of x y plus 6 absolute of x minus 1 plus this minus 2. This is greater than, because now this is less than delta and this one too is less than delta. So we can replace them to have this. So this is absolute of y plus 6 delta plus delta. Now we need to figure out this. We have so many ways of finding out this. I'll give you one of the strategy that you can use. Very nice, simple. Because we want to get this y minus 2, I'm going to write this one like this. So I'll just take absolute of y minus 6, y plus 6, and write this one as y minus 2 because I need y minus 2. But the question is, what should I add to minus 2 so that I get 6 back? That's 8, so plus 8. Then I will use triangle inequality again here to have absolute of y minus 2 plus absolute of 8 is still 8. And now, this is less than delta, so this will be strictly less than delta plus 8. Then I'll go and do substitution. So this will be strictly greater, less than, so delta plus 8 times delta plus another delta. So this is going to be the same as delta squared plus 8 delta plus delta. Now look at this. As soon as I've gotten something like this, I can even look at the option. 10, this one is more than 5, more than 3, more than 2. Because this one is 8. When I add this one, definitely this is going to give us 1. So here I'm going to choose delta to be less than or equal to 1. So that when I plug in 1, 1, 1, this will be 1 plus 8 plus 1, which is going to be 10. So when I choose that, this is going to be the same as 10 delta. Then I'm also going to choose delta again to be equal to epsilon over the coefficient of delta, right? So that when I do the substitution, this is going to be 10 epsilon over 10. This is going to be given as epsilon. So how many choices? I chose this and this. So we are choosing the minimum of the delta it should be 1 and epsilon over 10. So this should be giving us B. Wow. Can I leave this question for you to do? We are finding the domain. So the domain here, x squared minus y squared shouldn't be 0. So y squared is never the same as this. Take the square root and y is plus or minus x. So this should be D. Redefine the function such that, okay, so let's redefine the function. So f of x y is equal to x minus y divided by x squared minus y squared. Is that right? Yep. Now, this is difference of two squares. So we can write this one as x minus y divided by x minus y and then x plus y. So this will cancel this and we can have 1 over x plus y. So now when we redefine the function by, doing cancellation, then this one, x is equal to y. If x is equal to y, then 1 over x plus x, and this is going to give us 1 over 2x. So this, when x is never 0, like x is not 0. Okay, so that's what's going to happen. Then now question is asking us to, now what is the limit as, x is approaching 1, 1. So limit as x approaching 1, x and y, approaching 1, 1 of f of x, y is limit x is approaching, x and y approaching 1, 1. Now remember that we simplify f of x, y because of the limit. This one, and we had, this. We can even use this, 1 over y. So this is going to be 1 over x plus y. Plug in 1, 1 and 1 over 1 plus 1. And this is 1 over 2. So we are going to have this. How can we redefine the function so that, okay, we want to redefine the function so that it continues here. Okay, fine. So let's think about this. Now, what we are thinking about the function is, now we have f of x, y, and we have the function x minus y divided by x squared minus y squared at y never the same as x, and we have at, this guy the same as this. So we want to redefine the function such that this and this are the same, like when I do direct substitution, are the same. But remember, anytime we have this one, it means that we need to talk about the limit. And when we found the limit, we saw that the limit of this one gave us 1 over 2. So it means that when we work on the limit on this at the point 1, 1, this is going to give us 1 over 2. So for us to make sure that this is continuous, this one too should be 1 over 2, right? So since the limit is giving us 1 over 2, this one should be 1 over 2. When we do the direct substitution, it should be giving us 1 over 2 so that the function will be continuous. There. We have like 30 more questions and I'm tired. Okay, do this one, right? Do this one. Okay. Okay, this one, I think this one I can just shade it. So this one is square root of x squared y squared, and this is just a cone, right? I mean, it's just having something like this one is like coming like the circle, but this is going to be like the cone. And this one is this one. And what is this one? This one is the upper hemisphere. When we start, you will see the reason why we are saying that when we start sketching, we will see how we are going to get all this done, right? So the upper hemisphere is something like this. When I have my 3D, I'm going to have, let me see, a circle on the base, on the domain, and then I have something like this. Yeah, so this is something like upper hemisphere. And then when x is the same as y, and we are going to have the rectangle hyperbola with this one too. So this one is just shading from there. Okay. Should I leave this one for you guys to do it? Okay, let me show you what you can do here. Here, oh, I think we've done this one before. Yes. So here, let u to be equal to x squared minus y squared, and v to be equal to xy. So we just need, this will become uv. And we've done this one before, so please do everything. We need f1, we need f2, we need f12, we need f21, and we need f11, and we need f22. So don't forget, f1 is partial of f with respect to x, partial of f with respect to y. This is partial of, so we need to differentiate first with respect to x, followed by y. So this is squared, and this is going to be partial of y with respect to x, and this is partial squared f. This is x with respect to y, right? So we need to do y before x. And this one here is going to be partial squared x squared, and this is partial squared y squared. So this is what you are going to do. So please try this one. So from 46 to 49, I'm going to leave everything for you to do it, right? Try your hand on this. Use the tree. Let me draw the tree for you. This depends on you. I think we've done this before on, I think, yeah, up there. So finish with 47, finish with 48, finish with 49, and now let's begin with 50. So we want to find this at x is not 0. So at x is not 0 is this. So this one we can use the quotient rule. So f of x y is equal to x cubed y minus x y cubed divided by x squared plus y squared, right? So let's differentiate using quotient rule. So I'll say u, I'll say v. Now don't forget, we are going with respect to x. So my u x cubed minus x y cubed. So ux will be equal to 3x squared y minus y cubed. V is x squared plus y squared. My vx will be 2x, just 2x. So what is partial of x? This is maintain v, differentiate u, minus maintain u, differentiate v divided by v squared. So let's do that. V times ux is going to give us x squared plus y squared, 3x squared y minus y cubed. Then we are going to have minus what again? U times vx, so 2x times 2x, x cubed minus y, oh no, times y. This is just y. Minus x y cubed times 2x divided by x squared plus y squared. Now let's look at our answer before we simplify. Okay, so they simplify the top. This is crazy. So let's just pick the top alone and just simplify. So multiply this by this and have 3x squared, 3x to the power 4y, and this by this to have minus x squared y cubed. Now multiply this by this to have plus 3x squared y to the power 3. Okay, and then multiply this one by this to have minus y to the power 6. Is that right? Yes, of course. When we are multiplying the we add, so it should be 5. Is that right? Yeah, we add, so it should be 5. Minus, multiply this one by 2x, so 2x times this is going to give us minus 2x to the power 4. Now don't forget, minus here, so it's going to be plus 2x squared. Oh, there should be y here. 2x squared y cubed. So let's see if we can cancel some of the terms out. Anyone with okay, this guy and this guy are the same, so they are going to give us x to the power this, and this guy and this guy are the same, so you're going to give us 2x squared y cubed. Okay, they are also the same as this guy, right? Yes, so it's going to give us 4. And then last one is minus y to the power 5. divided by x squared plus y squared all to the power 2. So x to the power 4 y, x to the power 4y. Oh, there is 2 multiplying that, 2, 2, 2. Let's check our answer and see if we had it wrong. How did I take the derivative? Oh my bad. Is that true? Yeah, this is my bad. I think that's right? This should be this. This should be that, and this should be this. Please let's expand again. This time this 3. When I differentiate x squared, oh, okay. So we have this minus this one here. So now b is out. So let's take b out. We have 4x squared y cubed, but it is positive. Okay, this one too is out. So the solution is depending on this, whether this is minus or positive, but we have this. So we need to figure out where to get this. Okay, so let's see what is happening here. When I multiply this one by this, I have that. And when I multiply this 2 here by this, it should be 2, right? Of course. And 2 minus this should be 3. It should be 1. Okay. I don't know what is wrong here, but let me see. Let me see. This is u times vx. This is u and this is vx. Yes. So we are right. Okay, so this is the right answer. Let's say there is no option. So it's probably going to be this without the 2. So let's do 51, which will prompt us to see if we are getting things right. Okay, so we need f of x, y. Now don't forget y is 2. So our concentration now is on this one, 2, which is going to give us 2. So x, y here is going to give us limit k is approaching 0, f of x plus y plus k minus f of x, y divided by k. Okay, this one should be x. Then we need f of x, y, 0, 0. So limit k is approaching 0, f of x, 0, 0, minus f of x. Okay, this one should be k. I'm so tired. That's the reason why I'm messing up like this. Now, this is 0, right? So this is just going to simplify to limit k is approaching 0. This of 0 and k divided by k. So let's pick our solution that we had here. Let's send it down there, right? Let's just copy and send it down there. So the solution that we had here, this is fx of xy. So let's plug in 0 and k. So when I plug in 0 and k, 0k, 0 here will be 0, 0 here will be 0. Oh, this is still not going to tell us our final answer though, because all the x parts is going to 0. So this is going to be k to the power 2 or 2 minus k to the power 5, k to the power 4. This is minus k. So plug in minus k and limit k is approaching 0, minus k divided by k. And this is limit k is approaching 0 of minus 1. This is minus 1. Okay, so we are having D, but please check this one for me, right? Check this one for me and see if it was the options which was wrong. Okay, so verify it if you are here with me. Okay, so this one, before we take the derivative, we just need to simplify this, right? So what we can do here is we can say that 1 over r is the same as r1 plus 1 over r2. Let's find a. So this is the same as r2 plus r1 divided by r1 plus no, r1, r2. So I'm just simplifying this. Multiply this one by this, which is here. Then multiply this one by this, which is here, divided by this times this. Reciprocate this. Let's reciprocate this. When we reciprocate this, we are going to have r to be equal to r1, r2 divided by r1 plus r2. This is commutative, so I can bring this one here, I can bring this. So now we need to differentiate this with respect to r1 and differentiate this one with respect to r2. So I'm going to leave this one for you to do it. So use a quotient rule, pick u here, pick v here, right? And just use the quotient rule to do that. But don't forget, we are dealing with partials. And the same thing to this one too. You are going to use the same thing here, but this one we are going to need partial of r with respect to r2, and this one we need partial of r with respect to r1. So do this one and leave your answer in the comment section. I'm giving you a lot of exercise, and that's good. I think we've done this question, yeah, from up there. I remember, and the answer was this, right? Remember, we had something like limit k is approaching 0, k squared minus 7k divided by k, and I said we can do this, but you can also try it and see if indeed we are going to get d, right? So check it out from there. Oh, this is beautiful, beautiful. Let's try this question here. Can we use polar coordinates? Let's think about it. I don't think so. But let's think about this. X is approaching 1 and 0. Here I can factor y out and have this. And I can write this one as x squared minus 2x plus 1 plus y squared. Right? So I just want to group the x terms and then bring the y here. Now limit, I'm not going to write the limit again. I'll bring it later. X minus 1. Now this is the same as x minus 1 squared plus y squared. Is that right? Yes. Yeah, this is right. Because when I expand this, I need to get this. Now let me bring my limit now. Now I want us to do change of variable. Let's s to be equal to x minus 1. And this implies that s is equal to 1 minus 1, which is equal to 0. Do you know what is happening here? Now, with this one, means that x is equal to 1 and y is equal to 0. So I'm using what is here. So if s is equal to x minus 1, then I plug in 1 and get this. And then let t to be equal to y. So this implies that t is equal to 0 because y is 0. So it means that we are going to have new limit. S t is approaching 0, 0, right? Great. And then now, guess what we are going to get? This is t, this is s. So I'm going to have ts divided by x squared plus t squared. So I think this is beautiful. So we can try to, do something like, let's go along x, let's go along y, and see if the limit exists, right? And we can just get this one done. So the first thing that we can do is we can think about the equation of the line, right? And just work with something. So equation of the line where there is no slope intercept is y is equal to mx, but y is t and x is s. So we can do that. Limit s is approaching this 0, 0, and t is going to be ms, so it's going to be m squared here. Then x squared plus this is going to be m squared x squared. Let's try and see if we can simplify this. Limit x t approaching 0, 0. On the top is this. I can factor x squared out and have 1 plus m squared. And this is limit xt is approaching 0, 0. And x can cancel x, right? So it's going to be m over 1 plus m squared. So since this does not depend on this is going to give us m over 1 plus m squared. So the limit is not going to exist because now let's assume that when m is 1, if m is 1, we are going to have 1 over 2. If m is 2, we are going to have 2 over 5. So the limit does not exist, right? Depending on m. So it means that the limit depends on m and this does not exist. Okay. Oh God, this is nice. So we have u, which depends on x and y. As you can see here, u depends on x and y. And we have x, which depends on r, and s, the same thing for y. And we need partial of u with respect to s. So this is beautiful. Why? Because now I pass on u to x and I go to x. I pass on y to x, right? So this is going to be partial of u of x times from x to s plus partial of u to y and from y to s. So move from u to x and x to s and y to s here. So let's try and differentiate because I think the function is in its simplest term. Since we need this x with respect to s, partial of x with respect to s is going to be, now we need to differentiate this one with respect to s. R is constant, but when I differentiate e to the power s with respect to s, I get the same thing. Partial of y with respect to s. Now, this is the same thing here, but when I differentiate this, it's not going to be the same thing again because now, remember, this one was the same thing because I was differentiating the s, and I'm getting 1. 1 times the whole function is just the same thing. But when I differentiate this, I'm going to get minus 1 times s, and this is going to give us minus e to the power minus s. So we have gotten this guy and this guy. We need this guy and this guy. What is u? Okay. U is equal to the natural log of square root of x squared plus y squared. Oh, this is no good. And this is the same as x squared plus y squared, 1 over 2. Now, what can we do here? Very simple. This is going to be the same as, okay, we know how to differentiate the length function. So this is differentiate. D means I'm going to differentiate. This is 1 divided by u times u prime. So when you look at this, the length function, our u is x squared plus y squared all to the power 1 over 2, which is beautiful. But we need u prime. But this, because we are differentiating with respect to x and y, we are going to do it partially. So we need ux for the x. So this is going to be the power rule. Let's use the power rule on this. 1 over 2 drops down, and I have x squared plus y squared. Then minus 1 over 2 because I'm going to subtract 1 times, I differentiate what's inside with respect to, x, and I have 2x. So this guy is going to be 2 cancel 2, and I'm going to have x divided by x squared plus y squared all to the power 1 over 2. Great. Let me put this guy here. Now we will need uy. So uy is also going to give us 1 over 2 as the same thing, x squared plus y squared minus 1 over 2. But here, when we differentiate what is inside, we are going to have 2y. 2 cancel 2, and I have y divided by x squared plus y squared all to the power 1 over 2. Nice. Okay, so what can we do? This one is too simplified. Why? Advanced people, we are no good. Always we want to make things complicated. Okay, so now let's try and continue from here. So let me try and look for this. So partial of, with respect to s, is going to be 1 divided by, what is u? U is 1. U is x squared plus y squared 1 over 2, right? So that's what we have here. So 1 divided by u times u prime. U prime is this. So times x divided by x squared plus y squared 1 over 2. Simplify this. Multiply the top gets x. Since the base are the same, we add the exponent. 1 over 1 plus 1 over 1 is 1. So this is going to be x squared plus y squared. Nice for this guy. Now let's go partial of u with respect to y. This is also the same thing. 1 divided by x squared plus y squared 1 over 2 times, but that one we had this y divided by x squared plus y squared 1 over 2. So this is also going to give us the same thing, but this is going to be y divided by x squared this. So what are we going to do? We are going to multiply this by this. But let's look at our answer here. Our answer is in terms of s and y and s. X, y, and x. So let's see. So partial of u with respect to x is times. So we are going to have x divided by x squared plus y squared times this guy here. But this guy here is this. So we are going to use that. RS plus this is y over x squared plus y squared times, so this one here, which is this, which is right here, times this. This is minus of this. So this is going to give us minus r e minus s. Okay, now what can we do? This is the same as sr e s divided by x squared plus y squared minus y r e minus x divided by x squared plus y squared. Since the denominator is the same, you can combine them and have this minus y r. So you see advance, like you're gonna do a lot. You need speed. You need to practice before you can, finish what you are doing. So let me see. Okay, so we have, okay, they factored r out. So here, when I factor r out, I'll have x. Oh, this is not good. I'm now really seeing that students, people are struggling. So the answer should be this one. Yes, that's 56. Okay, I think we've done this, right? Yes, we've done this. Yes, we've done this. Yeah, I remember having z moving to x, y, and then this moving to r and this moving to theta. But you can also do it, right? So try this one too and leave your answer in the comment section. I can write this one for you. R is, so because we want to get to r, go to x first before you get to r. So z, go to x first before you move from x to r, plus z, go to y first, then you move from y to r. So use this one and then just do it. But I feel like we've done it. Yeah, I think so. You square something like this. Yes. And then we did something like this. Yes. And then we did something like this too. Yeah. Yeah, this is true. So do them and then leave your answer in the comment section. Okay, let's do this. We're almost done. We're almost done. We're almost done. So this one, we want to redefine the function. So here, we need to use long division so that we can factor the top. So x cubed minus y cubed. X goes here, x squared. X squared times this is x cubed. X squared times this is minus x squared y. Put in brackets, subtract. This minus this will be 0, so it's going to be left with, this has no term here, so it's going to be just 0. So I just want to bring this one first. So it's going to be 0 minus of this. So this is going to be x squared y minus y cubed. Now x squared goes here, x goes here, plus xy. when I multiply this one by this, so what I'm doing is I divide, right? So here, because I want this one to go inside this, I divide it by x. So one of the x will cancel, I have this. I want this one to go this one, I'll divide it by x. One of the x will cancel and you have this. Multiply it back and have x squared y minus xy squared minus divided by. So I multiplied this one by this and this one by this. Now this and this will go to 0. This and this will be positive. So I'm going to have xy squared minus y cubed. Now x divide this, it will be left with y squared. So plus y squared. Now multiply this by this and we are going to have xy squared minus y cubed. And this is going to give us 0 because when I subtract, everything goes 0. So indeed, this is a factor. So we can write f of xy as x minus y, right, times, bring this one down small, times x squared plus xy plus y squared. So we just need to multiply this by this. And this is going to give us what is on the top. Divided by x minus y. So this is what we wanted to do so that we can cancel this. And we are going to have x squared plus xy plus y squared. Okay, so redefine the function as what you are going to get here. X squared plus y squared plus xy. So redefining the function is going to give us this. Great. Great. Find the range. Wow. So range, now because we want to find the range of x, y, z of square root of 16 minus x squared minus y squared minus z squared. Now remember, under the square root, always this is greater than or equal to 0. So it means that 1, our range is just going to have 0 less than or equal to x and y. So this is one of the choice, but we need the upper bound here, right? Because since this is greater than or equal to 0, this function is greater than or equal to 0 and it's the same as this. So we need upper bound. Since we need upper bound, I can write this guy as this: 16 minus x squared minus y squared minus z squared. This. Then I will let what is under the parentheses here, x squared plus y squared, to be equal to k. So remember what is here, because this, we don't want it to be negative. What is here cannot exceed this. So set up equation saying that 16 is the same as 16. But here now, I want to subtract a constant from 16. So if this constant is 0, then it's going to be the same as 16. But if this constant is not 0 and let's say it is 1, it means that this will be greater than this. So it means that we can write this one as less than or equal to 16. But we are saying that k is equal to this. So we are going to have 16 minus x squared plus y squared plus z squared less than or equal to 16. Now we want to form this. So we take square root on both sides. 16 minus x squared plus y squared plus z squared less than or equal to square root of this. And guess what is going to happen? This guy here is going to be less than 4. And remember, we said this that we have here is the same as the f of x, y, z. So f of x, y, z is less than or equal to 4. And this guy here is less than 0. So we are going to have it less than 0. So this is going to have 4 here. And our answer should be this. So strategy. Anytime you have a function of this form, just take square root of this. So if this is 1, square root of this is 1. So it should be 0 to 1. If this is 4, 2, 0 to 4. If this one is, let's say, 3, square root of 3 is still 3. So this is going to be 0 to square root of 3. Right. So that is the strategy there. We have like 7 more questions to go. Okay. Now, how can we solve this function here? Right? So we have x squared plus y squared, but these functions are inside the square root. So what can we do here? All right. So this is good for us to use the squeeze theorem. And as soon as I see this, I see that this does not exist. Why? Because I'm thinking something. Okay, maybe what if you are wrong? Okay, let's see if it is true. Let's use polar coordinate. X squared plus y squared is equal to r squared, right? So it means that when x is 0, y is 0, r2 is going to approach 0. So I'm going to have limit r is approaching 0, right? Because s is 0, y is 0. So 0, 0 is going to give us 0 is equal to r squared, and this is r, which is equal to 0. So on the top, I'm going to have sine of something over r squared. Now, what is x? We know that x is equal to r cos theta and y is equal to r sine theta using this. Don't forget, always draw if you forget this. This is x, this is y, this is r. So this is what is going to happen. So on the top, we are going to have r squared sine theta cos theta. So this is what we are going to get on the top. So when I multiply x to y, so now r will cancel r, and I'm going to have limits r is approaching 0 of sine. No, r cancel r, and I have sine of this. Now r is approaching theta, and the function has no r, so this is going to be sine of cos of theta, sine of theta. And since this depends on theta, the limit does not exist. Why? Because if theta changes, the solution here too is going to change, right? So we are going to say that this does not exist. We can also use squeeze theorem to work out things. We want to find the domain of this. This is straightforward. The natural log function is strictly positive. So 9 minus x squared minus 9y squared should be greater than 0. Now, they were trying to write this one in the form of the, let me call it the ellipse equation form, right? So it means that now this is 9 is greater than x squared plus y squared. This is the same as 9. This is the same as x squared plus 9y squared less than 9. So the ellipse here, we should make sure that this is 1. So we are going to divide this one by 9, this one by 9, this one by 9. And we are going to have x squared divided by 9 plus y squared less than 1. So we have all of them less than 1. We have y squared, but there is no minus, so this is out. This is out. So the answer should be C. Right. Few questions to go. Describe the sets of the point by the domain. Okay, that's what we just did here. So as I told you, this is an ellipse. So this is going to be ellipse. Since this one is less than 1, it's going to be something like this. And we are going to be shading in, but because this is strictly less than, we are not going to include the boundary. So we are going to say that this is ellipse excluding the set of ellipse excluding the boundaries, right? So that's basically what is going to happen when we sketch the graph from here. So this is going to be x squared divided by 3x squared plus y squared divided by 1 less than 1, and x over 3x squared plus y over 1 or squared less than 1. So if I want to sketch this, the major axis is the one with the greatest radius here. So this is 3, this is 3, this is 1, this is also 1. So the ellipse is going to be something like this. Good. And we are going to shade inside. So you see that I'm using the dotted line on the boundary because we are not including it. So that will be the set for 65. Now find f of 3, 2 if this is equal to this. Let's just do substitution and see what is going to happen. 2, this is equal to 3 natural log of 2 squared minus is it 3? Yeah. So 3, 4 minus 1, oops, 4 minus 3. 3 times. Natural log of 1 is 0. So this is 0. Okay, this is very simple from here. Just do direct substitution and we are done. Okay, this one we are going to use, polar coordinates. X, theta, y, r. So what is going to happen here is x squared plus y squared is equal to r squared. So we are going to have, when x is 0 and y is 0, this is also going to be 0. So we are going to have 0 plus 0 equals r squared, and r is going to be 0. So here, limit r is approaching 0. What is x? X is equal to r cos theta, and y is equal to r sine theta. So this is going to give us r cos theta sine of r squared divided by r squared. One of the r can cancel out to have r greater than r approaching 0. Cos of theta sine r squared over r. Okay, so something great is going to happen here. What is going to happen? Let's try and form the squeeze theorem, right? So we know that sine of r squared is bounded by this. I need this by multiplying by cos. So we multiply through by cos theta. And I have cos theta sine r squared cos theta. I want this one to be divided by r. So I divide through by r. And I have this r. And then this is going to be, I feel like what I'm going to get here is not properly, I feel like when x is approaching 0 here, this is going to be undefined, but we don't have undefined here. Let me check my solution again to see that everything that I'm doing here is right. So x squared, y squared is r squared, right? And this is that. One of them cancelled, and we have this. And this is not right, because I'm getting undefined here, because when you pick a limit as x is approaching 0 here, it's something we are going to get undefined here. So you can also check on this to see if I'm right, that we don't have options for 67. Okay, redefine this, try and do this, or let me just do it. We are almost done. So redefine means that just try and find limit of this. So we are finding limit as x and y is approaching 1 and 2 of 3xy. So anytime we want to find the limit, we pick the one which is not the same, like it's not equal to. So pick limit of this as s is approaching this. And here we can do direct substitution to have 3 times 1 times 2. And this is 6. So we need to redefine this by making this one 6 so that the function is going to be continuous. Set of points such that this is continuous. Okay, exponential function is a continuous function, but because we have e to the power x divided by y, assuming that y is 0, the function will be undefined. So the function will be continuous except we take y out. So when we take y out, this function is going to be continuous. So I think D will be the better option. Yeah, as soon as y is not 0, we can pick x. X can be 0, right? When x is 0 and this is not 0, 0 over 1 is still going to be 0, and we are going to get. Okay, this is our final question. Final question. And this we need f2, 0, 0. We are going to use the limit definition. So f2 of xy is going to be, don't forget, this is y, because it's 2. Limit k is approaching 0, f of x y plus k minus f of x y divided by k. Now we need f of 0, 0. So f2 of 0, 0 is going to be limit. I'm so tired. I'm so happy that we are done, finally. k minus f of 0, 0 divided by k. F of 0, 0 is 0. So we are going to have limit k is approaching 0, f of 0 k divided by k. So we just need f of 0 k. Let's plug it inside this function here. So f of x y is equal to x cubed plus y sine of 1 divided by x squared plus y squared. Is that right? Yes. Plug in 0 and k. This is going to be just k sine of 1 over k squared. So now let's try and plug it in and see what's going to happen. Limit k is approaching 0. K sine of 1 over k squared divided by k. It can cancel out and we have limit k is approaching 0, sine of 1 over k squared. Let's go and see our options. Okay, I think we have something beautiful here. So let's go to this. Yeah. All right, so this is the last video. I'm so tired, but I'm glad that I was able to go through this successfully. I wish you all the best in your quiz and see you when we start our videos on Tuesday.